The 2019 total lunar eclipse gave astronomers a unique perspective on the Earth's ozone layer. It's today's Talkin' Science Story of the Week. I'm Matt Miller, you're on Trekzone. Oh, and by the way, we're 12 days into our August campaign for 2020. Can you help us help Guide Dogs Australia? Beam over to bit.ly/TZ Guide Dogs and donate to our pack now.
With the latest science and space news 5 days a week across Apple Podcasts, Spotify, Google Podcasts and YouTube. This is Talkin' Science with Dr. Brad Tucker and Matt Miller.
And Brad, into our stories of the week. First up, Hubble has used last year's total lunar eclipse, the one in January, to study the Earth's atmosphere, which is not only giving us some insight into the Earth's atmosphere, but also exoplanets as well.
Yeah, so this is kind of a cool, neat idea. Now, people have done similar things in the past. It's the first time something like the Hubble Space Telescope was used. Because the idea is we want to find signatures of planets that have atmospheres, especially things like the ozone layer. The ozone layer we know is quite critical to the composition of our atmosphere. It's also critical to how life is and survived on the Earth. So we want to find those signatures. And so the big question always is, what are those signatures like? What did those signatures in space look like for other planets around other stars? And the best way to detect the best way to find that signature is to know exactly what it looks like. And the only place we can guarantee has an ozone layer with life is this planet. So it's a really great way of tying something, fairly straightforward and simple into the help in searching for habitable planets in the solar system.
And the way that astronomers did this one is that they used the moon essentially as a mirror. They were studying the reflection of sunlight as it passed through the Earth's atmosphere and then reflected back towards Hubble.
Yeah, you can never look directly at the Earth. The Earth is just way too bright. We're a very bright thing in space. So what you have to do...
Yes, we are.
So you have to look at our shadow, because that's actually what's happening during a lunar eclipse, right? A lunar eclipse, the Earth is in between, so to speak, the sun and the moon. The Earth blocks the apparent light from the sun on the moon. We cast a shadow out into space. We cast a big shadow. That shadow goes over the moon. And when the alignment is quite perfect, so to speak, you get a little bit of light skimming the Earth's atmosphere, landing on the moon. So the reason a lunar eclipse is red, or what we call a blood moon, is you're actually seeing a little bit of atmospheric refraction. So essentially you're seeing a little bit of sunrise and a little bit of sunset landing on the moon. So you're finding just a little bit of a way to measure just enough atmosphere on the moon without it being terribly bright. And then you can use it when the moon isn't in the lunar eclipse. So, you can follow the moon going into the lunar eclipse and follow the moon coming out of that shadow. And you can see how the colors, how the composition, how those signatures change, and detect what the signature is of the Earth's atmosphere and ozone layer.
Now, this is the first time that a total lunar eclipse has been captured, not only in ultraviolet wavelengths, but also from a space telescope. Some of these observations have been done from the ground before, but like I said, first time from space, basically.
Yeah, and ultraviolet is key. And in fact, that's what I work on, is where we launch these high-altitude balloons that have telescopes on them to look in the ultraviolet, because the ozone layer, which sits between just under 20 kilometers up to about 40 kilometers, just shy of that blocks most of the ultraviolet light. Now, that's good for us here on Earth. We don't get sunburns, therefore, we live. But it means when you want to look at ultraviolet light, you're not seeing a lot of it. So if you're looking at the ultraviolet light, you're going to actually be able to see the signatures of ozone, because if you're looking at the optical, colors we can see with our eyes, that light's already blocked. And so by looking in space, where we can detect the ultraviolet light, and then we can look for the signatures that absorb or interact with the ultraviolet light the most, and that is the ozone layer. That is the key part of looking at this, and that's why the Hubble Space Telescope was critical.
And it really just gives a calibration for exoplanet research. Knowing what we know about Earth, we can use that as the baseline for when we're studying those exoplanets.
That's exactly right. And so it's a really kind of cool, straightforward way. All right, we find the pattern now in space. We know what this looks like. What variations can we see? It reminds me when I was working on the Kepler Space Telescope on April 1st, one day, there was in one of the field configurations, Earth was going to pass through the field of view. So NASA, we were going to release a statement saying that Earth has found a planet with life. We just didn't know if it was intelligent life. It was April Fool's Day. It's a really cool way of sometimes using space telescopes. And the reason I brought that up is Kepler actually looked at the data from Earth because what they wanted to see is what planet has a lot of artificial satellites, and does that give off a signature? Earth. We can use Earth as this calibrator for looking for Earth-like things in the universe.
And it's the best planet that we know.
So far, I mean, we're pretty conceited, but I think it's justified in this case.
Well, Brad, tomorrow we're going to be diving into the hot blob in the Large Magellanic Cloud. I'm looking forward to learning about this one.
And it's not a monster.